Dude, this Python script is gonna take 80 hours to process all these data sets. I'm just gonna apply to jobs, man.
Bro, you didn't even make that a parallel HPC workload, right?
My PhD advisor, Claude Sonnet, he talked about it. It looks way too complicated.
Bro, I gotta show you Constellation. Constellation is an HPC native IDE with seamless AI integration. Bro, check this out.
All right, welcome to Constellation. We're going to go through the full flow here, starting with the user sign-in. We're going to create a new project for the demo and start with creating the first node in our dependency graph. So here we're going to do a single CSV file input. Our system supports a multi-file input through zip, and it pipelines correctly using the dependency graph, but for the sake of the demo, we're doing a single file here.
Okay, so you can see right here that the AI on the right created a directed acyclic graph that efficiently breaks up the tasks that we asked it to do. And these are through a series of compute nodes, input nodes, and output nodes.
Yeah, so the first run we're going to do is just a local run. This hits our backend and it stores everything in memory. It's good for small inputs to verify your pipeline. And next, we're going to deploy to cloud to actually spin up the compute.
Yeah, but before I do that, even though this is AI powered, you still obviously have granularity, like granular control over the code. So if you wanted to change things like what I just did right there, changing the window to 8 instead of 5 for the time moving average compute cluster, you can do that.
Yeah, so with the deploy to cloud, each of these tasks are submitted to a queue of batch jobs, which are being dispatched to EC2 workers. So this is why it's taking a minute, because it has to do all of this batching. This overhead is fine for big files, which is what this flow is intended for. And these are dynamically spun up and spun down to handle the workload. So this goes in the order of the dependency graph visible on the left. Each node is an actual node. And this would be a great place to replace the AWS with the NMC squared infrastructure. Even though we could have done this completely simulated, we wanted to see how it would work in a production environment using AWS.
Yeah. And so one thing I want to highlight here is you can actually see the architecture stepping through the different nodes. So you can see that the two moving average nodes are currently running. And this really may take a second, but this is an interesting issue that just popped up, right? So we have an error. The code was referencing a variable named input data, which was not defined. And this caused the deployment to fail. And what you just saw pop up right there is something we call autopilot. Pretty much, it's an AI assistant we've built that monitors your deployments. If there is an error, it will proactively identify the error, fix it, and then tell you like what went wrong. So now that it fixed the error, we can redeploy. And this time it should succeed since the exact same code worked locally. While that's going on, we would like to just show you some of the other features, right? In addition to the 3D graph, we have a 2D graph, we have a 3D view. It's really nice, helps you visualize everything. The way nodes are added is pretty intelligent. It tries to keep this like top-down view instead of just randomly throwing them around. You can manually add new nodes, right? Like compute 1, just as an example. You can delete specific nodes. And what we have seen here is that the compute workload has finished. So I will click on the output. You can see the output, and you see here, there's an AI analysis tab. This is meant for people who may not be super technical, walks you through everything pretty much, walks you through the pipeline, walks you through how everything the AI did relates to the intent, and walks you through how the actual output data relates to what you are asking. We also have a console integrated to the AWS server, so you can see everything live.
Dude, thanks. This is only gonna take 3 hours now.
Thanks for watching our demo, and let's unlock your compute galaxy.